So what we're going to look at next is about arc length. First, I want to explain what the difference is between the arc length, which is the red portion here, AB, and the arc measure. So arc length versus arc measure. Now when you say arc measure, this is given in degrees, right? Because we had a theorem previously that says whatever the angle here, say theta, that's the same degree on the corresponding intercepted arc. So the central angle and the intercepted minor arc, they're equal to each other. But what we're trying to get here is not the same as a degree measure. So an arc length pretty much is, imagine you're measuring this with a string or a yarn. So the length of the yarn that corresponds to the length of arc AB, that is measured in units. So while an angle is measured in degrees, an arc length is measured in units. So how are we going to do that? Let me erase this one. So what we need to do is to just convert the degree measure that we know from our previous theorem to a measurement that can be expressed in linear units. Let's say centimeters or millimeters and so on. So how are we going to do that? We're just going to set up a proportion. So we know that, let's say this is 60 degrees. So if this is 60 degrees, the central angle, then the corresponding minor arc is also 60 degrees. So we're going to look at what fraction of the whole, of the entire circle, okay, or of the total angles in the circle is 60 degrees. So that ratio is actually given by the right-hand side of this equation. So this is measured in degrees. There you go. So the numerator is actually the central angle versus the total angles in a circle. So total angles in a circle. That's a circle. Okay. So that's one ratio. Now we're going to write a proportion. So we're going to make it equal to another ratio. So this ratio on the left-hand side, the arc length is what we're looking for, right? And this red arc here, okay, the length of that is actually just a portion of the circumference of the entire circle. So pretty much you're trying to find the length here. So this is your arc length over the circumference. And we know that the formula for circumference is either 2 pi r or pi d. So if you're going to write or rewrite this formula in another way, this is pretty much the same as arc length over circumference is equal to the central angle over 360. So simply put, we're going to get the ratio of the arc length over the entire circumference of the circle, which is similar to, the ratio of the central angle over the total degrees, which is 360 in a circle. Alright, this formula has a lot of versions. You can actually, multiply 2 pi r or the circumference to the right hand side. So you would get something like, let me show you what's in Schoology. So you will get something like this. See where the 2 pi r, went to the other side. It was multiplied to the right hand side instead. So that's another format. So the formula will explicitly give you what the arc length is. But, for me, I think it's easier to remember it this way. Length over circumference is equal to angle over 360. So that whichever quantity you're looking for, whether you're looking for arc length or whether you're looking for the central angle, then, you could just isolate whatever variable you need. I'm going to show you examples next. So let me change my screen. Let's go to example 2 on arc length. Okay, so for the first one, oh, it's too small. Can you see it? Alright, so for letter A, let's write down the formula again. We need the length over circumference is equal to angle over 360. So for letter A, we need the length of AB. So AB, the circumference is 2 pi. What's your radius? Your radius is 8. Is equal to, the central angle is 60 over 360. Now, if we want to isolate AB, then we get AB is equal to, you can actually reduce this, but I'm going to keep it for now. 360 over 360 times, 2 times 8 is 16, so that's pi. There you go. So, let's reduce this. You can divide each by 60. So you will get 1 over 6, right? Times 16 pi. Now you can reduce this again by dividing by 2. So this will be 3, and this will become 8. So the simplest possible answer, if we leave it in pi form, will be 8 pi over 3. There you go, 8 pi over 3. So if you want to round that off to the nearest tens, okay, let me do it on my phone. Give me 1 sec. So we get 8 times, we're using 3.14 for pi, and then we're going to divide it by 3. So it's approximately 8.4. So this one will be, where's my pen now? So it's going to be 8.37. So I should make it 8.4. There you go. So that's for letter A. Now let's go to letter B. For letter B, we need the circumference. So let's write down our formula again. Length over circumference is equal to angle over 360. So they already give you the length. How do you know that this is the length? This is the length because it's measured in linear units like inches, meters, etc. Okay, so the length is 4.19. They don't know what the circumference is, so let's just leave the C as a variable. The angle is 40 degrees over 360. Now from here, you can actually reduce it already if you want. So this is 4.19 over C is equal to, if you divide this by 40, you will get 1 over 9, right? So that's going to be 1 over 9. So now you're going to cross multiply. So to cross multiply this, C times 1 is a C, and then for 4.19 times 9, whatever that is, that will be your final answer. So let's reduce that to, or let's round that off to the nearest hundreds. So 4 times 4.19 is, okay, it's 16.76. So we're going to make it 16.8. So this is 16.8. So the circumference is 16.8. Alright. Okay, now for letter C, let's write down a formula. So arc length over C is equal to angle over 360. Now, what are they looking for here? They're looking for a minor arc, right? But we know that a minor arc actually has the same measure as the central angle. So, in order to find the minor arc, all we need to do is find the central angle. Our arc length here is 44 meters. So 44 over the circumference, which is 2 pi. Your radius is 15.28. There you go. Is equal to the angle, which is the same as the arc that we're looking for, over 360. So to get the angle by itself, just multiply the 360 to the other side. So you will get angle is equal to 360 times 44 over whatever this one is, 2 pi 15.28. So let me do that calculation and let's see what we get. So it's 360 times 44. So the numerator turns out to be 15840. Now the denominator is 2 times your pi is 3.14 times 1528. So this one for the denominator is 95.9584. So let's divide the numerator by the denominator. Or if you have a scientific calculator, you can do that fast. I'm only doing it on my phone. That's what I have right now. So I'm getting approximately 165.1. So it's actually 165.07. So I just rounded it off. So that means the minor arc here, this is the minor arc RS, is actually 165.1. So those are some examples on how to find the arc length or how to use the arc length formula. So after this, you're going to go back to Schoology and do the check for understanding. Good luck.